Why are C++ variables optimized away in debugging? Imagine trying to look at your code and see what each variable holds, but suddenly the debugger says the variable is gone. Frustrating, right? Well, that's what happens in C++ debugging when variables seem to disappear. So why does this happen? Let's break it down. When you compile C++ code, the compiler tries to make your program run faster and take up less space. To do that, it applies various tricks called optimizations. These tricks can change how your code looks at the machine level. One common trick is to remove variables that the compiler thinks are unnecessary. If a variable is never read after being assigned, the compiler might decide it's safe to get rid of it. This is especially true when you turn on optimization flags like -01 or higher in your compiler settings. The compiler might also store variables only in CPU registers instead of memory. Registers are tiny storage spaces inside the processor that are super fast but limited in number. If a variable is stored only in a register, the debugger might not be able to see it because registers are not part of the program's memory map. Another reason is code motion. The compiler can move code around to make it run more efficiently. This means some variables only exist temporarily during certain instructions, making it hard for the debugger to track them. Also, if your code never takes the address of a variable using the ampersand symbol, the compiler is free to optimize it away. When you are debugging with tools like GDB or LLDB, these optimizations can cause variables to be missing or show as optimized away. The debugger relies on debug symbols that map source variables to memory locations. When the compiler removes or transforms variables, the debugger can no longer find them. To fix this, many developers compile their code with optimization turned off by using the -00 flag. This keeps variables intact and makes debugging easier. You can also use debug builds that include debug symbols and disable optimizations selectively. Some tools even offer features to help see variables in optimized code, like deoptimization or special debugging modes. For example, Visual Studio has a feature called dynamic debugging that can sometimes restore variable visibility even in optimized code. But keep in mind, turning off optimizations might make your program run a little slower. So, understanding why variables are optimized away helps you decide how to set up your build environment for debugging. If you want to see your variables during debugging, disable or reduce optimization flags. That way, your debugger can do its job and you can find bugs faster.